here's a classic example. It's the summation n equals 1 to infinity of n to the n on top divided by n factorial on the bottom. That exclamation point is n factorial. And in case you don't remember what that is, here's a little quick definition on the side. N factorial, what it means is start multiplying, begin with n, and decrease by 1. So it's n times n minus 1 times n minus 2, and you keep going all the way down to 1, all the way down to 3 times 2 times 1. So for instance, if you just had 3 factorial, that would be 3 times 2 times 1 equals 6. 4 factorial would be 4 times 3 times 2 times 1 equals 24. And 5 factorial would be 120, and so on. But the useful thing is that n factorial equals n times n minus 1, and then it keeps going down. So you could just put the factorial on the second term. Order of operations here means that the factorial just goes on the one that it's closest to. In other words, you do factorial first and then multiply. So n factorial is equal to n times n minus 1 factorial, and the n minus 1 factorial is done before you multiply the front n on. So it's the same thing as the line above it. N minus 1 factorial means you start with n minus 1 and count down to 1. Alright, so there's that. And then before we finish this one, I should look back up a little bit at this limit. This is a little bit of review. Hopefully you've seen before, but if not, it's easy enough. It's a memorization fact. The limit as n goes to infinity of 1 plus 1 over n to the n is equal to e. It's actually another way of defining the number e, besides just the number whose exponential function curve has the slope equal to its y value. This is another way of defining the number e. It's the limit as n goes to infinity of 1 plus 1 over n to the n, which at the top of this page of notes I did put in some calculations, which you can do for yourself. If you put in the number 1 to 1 plus 1 over n to the n, it comes out to, what would that be? 1 plus 1 to the 1, so 2. Put in number 2, you get 1 plus a half, and then square it, and that gives you 1.5 squared is 2.25. And you can see some more there. And if you put in really large numbers like 10,000, you get 2.718. And a million, you get 2.718282. They're getting closer and closer to being e. So that's a quick way of figuring out what e is. If you just put in a big number into 1 plus 1 over n to the n, you'll get pretty much what e is. Alright, so that's a limit to memorize. 1 plus 1 over n all to the n is equal to e. And you could also combine the fractions inside that parenthesis. If you get a common denominator of n, you can make the 1 into an n over n, and then get n plus 1 over n all to the n. Alright, so back to the problem. Now there's maybe some new stuff, maybe some review if you've seen it before. The problem here says to find out convergence or divergence for the summation n to the n over n factorial. And again, this is one where I would tell you to use the ratio test, although whenever you see factorial, that's a good hint that the ratio test is what to use because it works out real nicely. So, first of all, I don't need absolute value bars on this one because there was no minuses. On the previous problem I had to get rid of those negatives, but this one, everything is already a positive number. So, first I'll put in the n plus 1s, all three places, n plus 1 to the n plus 1 divided by n plus 1 factorial. You need parentheses around those. Then I'll divide by the original, so I could just go ahead and multiply by the flip. So times n factorial divided by n to the n. And now you can do the algebra. First of all, for the n plus 1 factorial, I'm going to change that into n plus 1 times n factorial. Basically, I pull off the first term and then factorial the rest of it. That's like what we did in the box, but with n plus 1. And then let's see what we get. So on top, I also turned n plus 1 to the n plus 1, well, I just looked at the common base now. Top has n plus 1 to the n plus 1. The bottom has n plus 1. So that means that I'll have just that n plus 1 to the n left on top. That's where that came from. The n factorials cancel. That's all gone. I am left with an n plus 1 on the bottom and n to the n. That came from the original. Oh, I just didn't cancel it yet. I just left the n plus 1 on the bottom and the n plus 1 to the 1 times n plus 1 to the n on top. All I canceled in the first step was the n factorials. Now I'm going to cancel the n plus 1s on top and bottom. Same as finding the reducing the 2 with the same base, n plus 1. So that's what's left on top is n plus 1 to the n. What's left on the bottom is an n. And you can write that as n plus 1 over n all to the n, which is now taking the limit equal to e. It's the limit that we just wrote in the box up there, but I did write, this one looks like a single fraction, but you can break that fraction up and make it 1 plus 1 over 1 n to the n if you want. But that's the fraction, that's the expression n plus 1 over n all to the n, that when you take the limit you get e. Now e is 2.718. That's bigger than 1. So this diverges.